Module 1, Foundations of Immunology. 1. Historical Perspectives in Immunology. Let's start with a bit of a time travel. Imagine you are living in the 18th century. Plagues sweep through towns. People don't know what causes disease, some think it's bad air, some think it's divine punishment, others believe in imbalances in body fluids. Then, gradually, the science of immunity begins to take shape. The story of immunology really begins with observation. People notice something intriguing: if you had smallpox once, you usually didn't get it again. This wasn't explained scientifically yet, but it was a pattern that would change the future of medicine. One of the earliest recorded uses of this knowledge was in ancient China and the Middle East, where people practiced variolation, deliberately introducing material from a mild smallpox case into a healthy person to protect them from a severe form of the disease. Risky, yes, but it saved lives. Then came Edward Jenner in 1796, the British physician who noticed that milkmaids who had caught cowpox seemed immune to smallpox. He used material from cowpox blisters to protect against smallpox, and this was the birth of vaccination as we know it. From there, Louis Pasteur expanded the concept in the late 19th century with vaccines for anthrax and rabies. As microbiology advanced, thanks to scientists like Robert Koch, we learned that germs, bacteria, viruses, parasites cause many diseases. Immunology grew as the science of understanding how the body protects itself from these pathogens. Fast forward to the 20th and 21st centuries, and we've unlocked the molecular details of immunity, developed advanced vaccines, monoclonal antibodies, and therapies that harness the immune system to fight cancer and other diseases. So, immunology is not just a modern invention, it's the result of centuries of observation, experimentation, and life-saving insight. 2. Host-pathogen interactions. The immune system exists because we live in a world full of microorganisms, bacteria, viruses, fungi, and parasites. Some of these are harmless or even beneficial, but others can cause disease. The constant interaction between our bodies, the host, and these invaders, pathogens, is a dynamic battle. When a pathogen enters the body, it faces several lines of defense. Physical barriers, the skin, mucous membranes, and secretions like saliva and tears. Innate immune responses, rapid, non-specific defenses like inflammation, fever, and the actions of immune cells such as neutrophils and macrophages. Adaptive immune responses, targeted, highly specific responses involving B cells and T cells that develop over days but offer memory for future protection. Pathogens, of course, are not passive. They evolve strategies to evade or suppress the immune response, hiding inside cells, changing their surface proteins, or producing toxins. This back-and-forth adaptation between host and pathogen is what shapes the immune system over evolutionary time. 3. Introduction to the immune system. If I asked you to picture your immune system, you might imagine white blood cells floating in the blood, and you'd be partly right. But the immune system is more like an intricate network spread throughout your body, made up of specialized cells, tissues, and organs working together to protect you. It has two major arms. Innate immunity, fast, general defense mechanisms you're born with. Adaptive immunity, slower to kick in, but highly specific and capable of remembering past encounters. The immune system must strike a balance, respond strongly enough to eliminate pathogens, but not so aggressively that it damages healthy tissue. This delicate balance is central to understanding immune-related diseases. 4. Cells and organs of the immune system. The immune system cells are mainly produced in the bone marrow, which is one of the primary lymphoid organs. Another primary organ is the thymus, where certain white blood cells, T lymphocytes, mature. Secondary lymphoid organs include lymph nodes, hubs where immune cells meet antigens and coordinate responses. Spleen, filters blood and responds to blood-borne pathogens. Mucosa-associated lymphoid tissue, MALT, immune tissues in the gut, respiratory tract, and other mucosal sites. Key immune cells include neutrophils, rapid responders that engulf and kill microbes. Macrophages, versatile cells that ingest pathogens and signal other immune cells. Dendritic cells, capture antigens and present them to T cells. Natural killer, NK, cells, destroy infected or abnormal cells without prior sensitization. B cells, produce antibodies. T cells, coordinate immune responses and directly kill infected cells.